Thank you, Markus. Because we have a couple of people here being already the last 2 days with us, I have a completely different presentation for today, and it's not that much selling street lighting, it's talking about visions. A few words about my person. I'm dealing with HD-PLC already since 7 years, so I have a very deep knowledge how to create devices, how to create software for that kind of devices. We are using HD-PLC for street lighting solutions, and for that purpose we need to have an extremely reliable communication, because if that doesn't work, it's not only that you cannot talk with one of the smart meter gateways or something else or something like that. A complete segment in a city stays dark during night. Then you have a real problem, and I can tell you that's leading to less air than only the communication level. If the customer calls and says, do you know what the people tell us if the city stays dark? Additionally, I'm working in standardization for building automation protocols. We use that for our street lighting applications, and I all the time bring HD-PLC as a possible communication layer into that application. We will see that later. Our company is based in Australia. The German subsidiary, which has the brand name iciti, is a German GmbH. We are doing the smart street lighting projects worldwide, mainly in Europe, EMEA. Our strongest, largest customers are actually in Eastern Europe. We deployed around 250,000 street lighting poles, mainly with Nessum power line technology, but we have 3 installations running here in Germany using already HD-PLC. Since 2 days, we have a 5th sub-branch, which is called CareM, which is creating an AI-based ecosystem for assisted living. So what does the engineer do when his parents are getting older and need help? He's trying to find a technology-based solution so that we put that into a new company. If we talk about IoT, there are a lot of models to explain what is IoT, and it consists, of course, of things. We have a connectivity segment, and this connectivity segment, in my approach, is baseline communication. We have something like data models and protocols. I put something here which is, I hope, correctly in the smart meter segment, but we have building automation, we have smart city protocols like UCFi, which is a semi-standard because it's more or less proprietary, because it is driven by only 2 companies. We have security demands. Usually in an IoT environment you will find gateways. Not only something intelligent like the smart meter gateway, which is having a lot of legal requirements here in Germany to protect privacy, so it's more something like security, but only to convert data from a light-wide protocol to an IP protocol. And last but not least, we have analytics in the cloud, usually software as a service. This is where the leaf is. So you have to pay for data point per month or something like that. I'm at the opposite side. We are at the fixed side, and I just can tell you, in the past I had been working in a building that was a high technology hub, and from time to time there's a welcome party, and I had been drinking a glass of sparkling wine, and somebody, a young person, asked me, "Hi, what are you doing?" I said, we are doing IoT. Oh, what kind of cloud service do you offer? I said, nothing. We are making the things. And you will see, oh shit, we need that. Otherwise, there is no business. When we create IoT devices, at first we want to know what ecosystem are offering the chip manufacturers. We want to have everything on a single chip, making it small, making it cheap. And this is combined from my two friends from Megachips at SocioNext, an overview what can we find today in an HD-PLC controller. We have the hardware level, so we have a pretty nice CPU, we have a sufficient memory inside of the chip. We are having HD-PLC, PHY, Ethernet, serial ports, a lot of inputs and outputs. That's much more than we had in the last generation, by the way. The chips are using an external flash to boot up. We have hardware encryption. That's it, more or less on the hardware layer. Next layer is the core software, which is dealing with all of that pretty nice pieces of hardware, doing the HD-PLC protocol, doing the multi-hopping protocol to extend that. So what Tom and Keiko mentioned, that you can cross distances up to 10 kilometers. Newly introduced in Gen 4 is that we can find this real-time operating system, which makes software development much easier. Next layer is the ecosystem on the chip is offering very rich IP communication features. So you can run TCP/IP, you can run a web server, you can have authentication encryption using TLS. So everything is present there, that you can maintain the device using a web front end, and that you can, on top of the AES 128 on HD-PLC, that you can run safe operations, safe protocols. And again, one level higher, you will find automation protocols. We have in the industry, we are using the LON protocol, ISO 14908. But in building automation, it would be BACnet or KNX. In Smart City, there's another protocol called TORC. We are having protocols in the smart meter area or in the demand response area, like EEBus. I don't remember the EN. There isn't the EN for that already. And we can do user diagnostics. So the next is, what do we have to do if you want to build an IoT device using HD-PLC? The first is, you have to keep in mind, start with EMI and EMC considerations. Because if you don't do that and you fail later the tests, the compliance tests, you maybe have to restart from scratch. Next is a good power supply. My friend, a very good hardware developer, told me, all problems start with the power supply. And furthermore, we learned in the last presentations that we are using a spread spectrum from 2 to 28 megahertz, and your hardware design have to keep out that, so don't generate any noise in that frequency range, otherwise you will have not that good communication. We need to consider the coupling. Here we are talking about the mains line, but we are able in building automation especially using twist pair. Consider the I/O. The chips offer a lot of that. Not every IoT device which will implement HD-PLC necessarily need to have Ethernet. That's a cost factor. So if we put something on top of the streetlight pole, nobody has an interest that there is an RJ45 check. You have to consider if you need to have secure zones in your design. So not everything what are up to date or future security demands on a hardware design can be covered by the HD-PLC chip itself. If you need to have something like a crypto element inside of the CPU, you have to consider that. The next what you have to consider is resource usage. There are small footprint protocols and large footprint protocols. Yeah, for building automation, we have something which is called backward secure communication, which is tunneling all the old-fashioned backward protocol through WebSocket using TLS and with the central piece, which is distributing the message. This is having a big memory footprint, and you have to consider that because at the end of the day, memory inside of the chips is limited. Then you can consider to make your design easy, do you want to buy an HD-PLC module? If you open the evaluation kits from both of the vendors, you will see that they put a small tiny module inside of the HD-PLC evaluation kit, and there are third-party suppliers having that as the core business. We have Ecolinks, for instance, in the United States, which is their core business to make an HD-PLC module. And dependent on the I/O or the resource usage, you have to consider if you need to have a second CPU, which is running the main part of your application, or just simply driving the inputs and outputs. Okay, let's proceed. We made a streetlight controller. This is somewhere located in the streetlight pole at the bottom, where the cable comes up. Oops. We have Ethernet there that you can connect at the streetlight pole, and maybe a Wi-Fi access point or a CCTV. This is the current design, which is based still on Gen 3 of HD-PLC, but since we have since a few days very good results with Gen 4, we will move to Gen 4 to at first remove our old narrowband power line product line and make better devices. So we have HD-PLC here as a module. We have an application extender, STM32. We have energy measurement inside. Okay, I have to speed up. Thanks. I can talk it very. So the first design we did is, this is a hardware, HD-PLC, STM32, power management. We have a application protocol thing running directly on the HD-PLC CPU. As an alternative, you can put that, all that application-specific stuff to a more powerful CPU, and then it's alternate. We have been talking about profiles in the HD-PLC Alliance, or in Nessum Alliance now, to ensure that different applications can coexist on the same wire. So we have coverage between smart city and smart metering, because they will share potentially the same piece of wire. But we see additionally smart buildings, gas stations. Smart buildings, that was a project I had been bidding on in the past. Public housing in New York, heating and cooling by that fancy units, 140,000 of those, each with a load of 3 kilowatts. And if you turn all of them off, on, you have something of 500 megawatts. So it's like a power, they demand a power plant. And the special situation in the US is, if a building is exceeding the maximum load, they will turn it off. It's not a question to save money, like you mentioned. It's a question to have energy at all. And so the idea was, just turn that off, HD-PLC control inside. We can indoor, we can hook up surveillance cameras on light trucks in museums. Another application. Petrol stations. That's an interesting one because outdoor payment introduced the necessity to have Ethernet somewhere on the gas station, which is actually not present. Drawing new wires on a petrol station has a cost around 30,000 euro because the ground is sealed and you cannot only dig it up and put a new wire that needs to be tested at all. With HD-PLC you can have something like a spread Ethernet switch on the gas station in each dispenser, hooking up auto payment terminals. 802.1x authentication control, that's a very good use case because it's a niche. And how many gas stations do you think we have in Europe? Any number?
30,000.
3 times more. So we have all over Europe, we have around 100,000 gas stations with a minimum of 6 dispensers, so it's more than 500,000 potential devices. This is something we already found in the slides from Kuka. What is the use case for HD-PLC? What are the questions you can answer to have that, to find something to HD-PLC enable the device? I want to add something. This is wherever you have movable equipment. So if it has just a power plug, you can, with that power plug, you can maybe communicate. So that's part 1 of the application finder. Part 2 of the application finder is, if you are in a market like that, you can use the technology. Smart kitchens, freezer cabinets, we do it in the lighting, parking, fire protection where you have to cross long distances. We reduce the number of cables, and what is sometimes missed in buildings is we reduce the fire load of a building. If you see how the wiring in the building is increasing over time, sometimes you have a cable duct where you have 30 or 40 centimeters of cable, and if you have to go to the bottom cable, you have to dig somewhere and pull it out. And so HD-PLC is reducing fire load, which is a significant argument if you want to add a new technology. Finally, because we are in competition with other technologies, I like that slide because I didn't do that evaluation. That was a company in Switzerland selling different devices for Ethernet over power line, and they are selling G.HN. And what we see is that most of their customers reside at first in a file rate being below 1,000 megabits per second. I think here that was had with some G.HN enthusiasts not telling the truth. But the real file rate they tested in the flat was all the time below 100 megabits per second. And that's the same like what we can do with HDP.